share which one will cause the ball bearing to go faster? How many people say the straight track? How many people say the one with the dip in it? People that say the straight one, tell me why you think that. What do you think, Ryla?
It just has to get this and you have to go all the way down and then back up.
It doesn't have to go down and back up again? Okay. And why do you think that would be problematic?
Because it might lose speed.
So the ball is going to lose speed as it goes back up the curve. Okay, all right, good. Add on to that. What else do you think, John?
I don't think it has enough potential energy for the when it's at the very top. I don't think it has enough potential to make its way back up.
So the potential energy at the beginning isn't enough to take it down and back up, you're saying?
Yes.
Okay, Wesley?
I think in a longer race, the one that they put wind, but it doesn't have enough time to catch up to the one that's straight.
Okay. People who say, do you have something else to say about the curve track? The one with the
It's
dip?
also not interfering with it.
Interfering with what?
Like the dip is interfering with the
The progress of the ball?
yes.
Okay.
And the speed is just going all speed.
Okay. Anybody else have a reason why you think the straight track is going to win? John?
Say there's two roads. This one's going straight, right? And this one goes around just to get to the same spot. This one's gonna make it there fastest, right? Instead of, you know.
Because it's potentially going extra distance, you
Yeah.
think? Okay. Which one has greater potential energy? The straight one or the one with the curve in it? The curve one has greater potential energy. What do you know about potential energy? What does it usually turn into? Kinetic. Okay, let's see what happens. Right. Ready? Set. Go. Is that surprising to anybody?
Yeah.
No.
I'll do it one more time.
I thought it was like.
I like the sound. I like the sound.
Byron,
The weight?
they're the same mass.
Oh.
It's not a trick. They're the same mass.
Wait a minute.
See,
How does this go
Wait.
first?
yeah. Why do you think the one with the dip in it goes faster? What do you think causes acceleration, Michael?
It's body. It up in a beat.
So the fact that it has to drop down and then go back up? Okay, okay. Wesley?
I don't think it's like curved enough. I think it's not. I think that it's not curved enough. The second one's not gonna be going very fast.
This one?
Yeah,
Okay.
that one's not gonna be going fast. So then, therefore, that one.
Which one is faster from the start?
This one.
The curved one?
Yeah.
Why? What does it have more of again? Do you remember? More potential energy that turns into kinetic energy. I thought with you that it was going to slow down by the time it gets to here, right?
Like it's gonna like go back.
But think about it for a second. Even though it has to come back up, which one got a huge head start because of the potential and kinetic energy right from the beginning? The curved one. So even if it slows down here, it still has a giant lead over the other one. It just accelerates much faster. And you're right, when it comes back up, it does slow down, but it's already so far ahead. That's a big advantage. What would happen if I turn it around?
I still think it's straight. I think
Talk to your partner or neighbor about that. Tell them why you think that. Malia, what do you think? The straight one this time. Why do you think that? Okay, because before it went down this way, but now it's going the opposite way. All right. What do you think, Kristen? Straight one? Okay. Carlos, do you think straight or the curved one? The straight one? Okay. All right. What do you think, Mikey? Mikey, what do you think? Straight or the curve?
Curve.
Okay. How many people think the straight is going to be faster this time? Curve? Which one has more potential energy?
The curve.
The curved one. Let's see what happens.
Let's see.
3, 2, 1, go.
Whoa.
No, wait.
Want to see it again?
Let's go.
Wait, how was that one going fast?
Wanna see?
Yeah, how's that one going?
Now there
they're going
is,
the
if you look, it's hard to see. I'm going to slide this one over a little bit.
They're going the same speed.
There's this one.
Where does the ball speed up and when? Or that ball bearing, I should say.
Right at the top.
Like at that weird curve.
Yeah, you can say it out loud. Where?
No.
At the peak here, right?
Yeah.
Once it gets, the potential energy is kinetic, converted to kinetic. Also, if you look really carefully, there's a bit more of a decline in the second one. That was not meant to be a trick, it's just the way the track is made. I want to see it one more time. Yeah.
If you put it another way, you're not gonna happen.
The
You
way,
started up there.
this way, it won't, the decline goes this way.
Wait, what if
So,
you started it over
it'll,
there?
well, I'll do it. I'll do it for
I want
you.
to see that.
Oh yeah.
If you started that way.
The ball will go back.
That's so sad.
That's because this block is slower than the other one.
Oh.
It's never gonna stop.
There's not much friction, is
That's
there?
gonna stop for now.
Wait, just leave it.
It'll go.
That's so satisfying.
This one, let's see what happens when we put,
What if you started from the other one?
this block is the same height as this block. So let's put them side by side and see what happens here.
It's a little taller.
20 million.
There's a. We're gonna two techniques. 3. It's still a curve. 2. It's still a curve.
Yeah.
3, 2, 1.
What?
Why did it go so slow?
Wait, try
This one's not as high
Oh,
as
yeah.
as the other one.
on the big one and then
5. That's
So,
kind of funny.
what do we learn from that? What do we take away?
Kinetic and
What?
kinetic energy.
Well, yeah. Well, what did we learn about the speed of the ball bearing and potential and kinetic energy? Can you summarize it? Talk to your partner. What's your takeaway?